Hey guys, Mr. Harbinger here, and we're going to do a fast thing on exponent properties. Uh, it should be straightforward. I'm going to remind you of some things you've learned before. Maybe you'll learn a couple new things, and I guess we'll get going. These are pages 38, 39, and 40 in your workbook. And if you're following along, great. And if you're not, you can always print it off or get a paper copy from me too. We're almost at the end of the workbook. The quarter test is coming soon, in a couple weeks, and we're going to start Unit 2 here really soon. So just to remind you of the properties you do know that a power times a power, you can add the exponents. If that's like x to the 2 times x to the 3, that would be 2x's and then 3x's next to it, and it's 5x's. That's why we can add the powers. And then same deal with exponent division. You can subtract the powers. If you have like x to the 5th divided by x squared, 2 of the ones on the top cancel with 2 of the ones on the bottom, leaving you with 3. That's why you can subtract them. Anything to the 0 power is 1, except for 0 to the 0. If I told you like 7 to the 0 power, it's 1. If I told you a billion to the 0 power, it's 1. We could talk about why, but I don't think you find that as interesting as I do. And you probably know from before that a power to a power, you can multiply them, right? The power rule sounds like something awesome, but sounding awesome and being awesome are two different things. And then you have two versions of the distributive property. If you've got a power on the outside, you've got some stuff getting multiplied on the inside, you can toss it right in. And then same deal, hey, you've got a power on the outside and things getting divided, you could toss it right in. Which you may not have known as these two guys on the bottom. A negative exponent means flip it upside down, like take the reciprocal. I tend to think of negative people as down. So, maybe they move or something like that to feel better. That's a different way of saying it. Doesn't always work that way, but, sometimes. And then the fractional power. Now, I tend to say power over root when you want to rewrite it. So an example would be like x to the 4/3. If we're saying power over root, and that would be power over root, you can think of it as a root of a tree is way down low. And I don't know, like Superman's powerful, so he's way up high or something like that. But that's the same thing as, oh my gosh, there's my radical. The root is the thing on the bottom, and the exponent is the thing that's way up high, the power. So that's a new way to look at it for you. And we're going to practice some, and then I'm going to upload the following 3 pages also as an attachment, so you have that. So I'm going to do this one kind of slow, and then I'm going to speed it up, and then the same treatment, so by the end it'll be a little bit faster. But hey, x to the 8th, if you know what it literally means, it means there's 8 of them, right? And they're all getting multiplied together. So that's 4, that's 6, that's 7, that's 8, all over 2 of them. And it looks like that. And what you can do is you can say, well, this guy on the bottom and this guy on the top, they cancel. Same deal with this one and same deal with that one. Hey, what am I left with? 6. Which makes sense because if we could have just subtracted them, that'd be better. Now, for something like this one, there's a plain old x. You can secretly put a 1 on top of it, right? Anything, the first power is itself. And what I'm going to do now, instead of writing it all out and canceling it, although that does make some of you more comfortable, I'm just going to subtract. So I have x to the 6th over x to the 1. That's just x to the 5th. And then y to the 3rd over y to the 2nd, just y to the 1st. You could also write it without that 1, right? This is also correct. All right, what I really want to do here is say, okay, x to the 2 over x to the 5th. That's it. Oh, 2 minus 5 is negative 3. Ooh. That's possible and legal. But instead, I'm going to write it like a fraction and say, well, this one's bigger, so it's going to stay where it is, and I'm going to do the subtraction. I'm going to do this. If you thought about it as x to the negative 3, you know that I could write it on the bottom. The y to the 7th over y to the 5th is just y squared. That would have been like that. And that works. The bigger power tends to stay where it is, and it likes to be on the bottom in this case. And if you had written it out, 1, 2, 3, 4, 5, 6, 7, all over. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is literally what this means, right? I'm translating it. So if I have 7 y's on the top and 5 y's on the bottom, 5 of them are going to go, and these 5 are going to go, and I'm left with 2. That's where that one comes from. And then there's 2 x's on the top, and 2 x's on the bottom. That leaves me with 3 on the bottom. That's why there's a 3 on the bottom right there. So that's just a different way of thinking about it. If you want to write them all out, that's cool. If you don't want to, I understand. This is a correct answer. It's just a little bit... Hey, 5 to 0, 1. I love that problem. This should really be over here, and I think it was just formatted poorly. So there's a big difference for people. This is not just 1, right? The 0 power is only on the x, so only the x is catching the 0 power. This is really 3 times 1, which is just 3. That's very, very different than this, right? That's a different story. That's 3 to the 0 times x to the 0, which is just 1. So be careful, please. This one over here is going to be your best friend. It's a power to a power. We could just multiply. If you're not sure why, that's x squared is really this. And cube means, well, write that same thing 3 times total. Hey, there's 6 of them. That's why that works. Sorry, I'm moving my stool. I'm going to multiply the 4 and the 3 just to get 12. That's the shortcut. I don't want to do the whole expansion every time, but you can if it makes you more comfortable. All right, distributive property. Distributive property says, hey, that power, yeah, it's going on the inside. So x cubed, y cubed. And if you wanted, xy, 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 and we could just regroup them. Same deal. All right, this thing over here, this is where people goof up. This is probably the most missed question in the whole unit, usually, because they're like, I'm going to write it like that and write it really stacked. Because people get mixed up and they're thinking, okay, 2 to the third and then y to the 2. Okay, one of them gets multiplied and one of them is a power. Be careful, please. 2 cubed is right in your calculator. 2 times 2 times 2, 8. Y to the 2 to the 3 is y to the 6, right? We can multiply the powers. Just be careful. Fake answers are going to be things like 6y to the 6th, 8y to the 5th, 8y to the 8th. There's so many ways to goof this one up. If you were to have written it out, 2yy times 2yy times 2yy is really what the problem is getting at. And 2 times 2 times 2 is 8. And there's 6 y's, which is y to the 6th. All right, this thing over here. We're going to distribute all the powers first, and then we're going to worry about rewriting it. So that's really x cubed to the 2. It's not 3 to the 2 like 9. It's x to the 3 to the 2, and I think people will have a hard time with that. That's y to the 4th to the 2. And we got x to the 2 to the 4. This is kind of fun. All right, so I'm going to rewrite it, and I'm going to probably rewrite it in the margin over here. So x to the 3 to the 2 is x to the 6, right? We multiply them. Y to the 4 to the 2 is y to the 8th. We multiply them. X to the 2 to the 4 is x to the 8th. And y to the 4th is y to the 4th. And now we can rewrite it like we did on that rightmost division property problem. This guy right here, something similar. So I'm going to put my answer kind of down here in the bottom right-hand corner. The x is bigger on the bottom, so it's going to stay there. And I'm going to do the subtraction thing. Hey, 6 and 8, it's 2, right? 8 minus 6 is 2, and it's already on the bottom. If you wanted, you could think of it as x to the negative 2 when you subtract, but that just puts an x squared on the bottom. Up top, I think people are kind of comfortable with that. That is just y to the 4th. Hey, this one's bigger, so it stays on top. X minus 4. Sorry, x minus 4. 8 minus 4 goes right there. If you were really unsure, like you didn't know, what you could do in your graphing calculator is you could give them initial values. You could say something like x, there's a button that looks like this. It's a colon followed by an equal sign, and give it a number, like 5. And then do the same thing for y and call it like, I don't know what, 11 or something. Don't make them 2 and 3. Don't make them 1 and 2 or 0 and 1. Try to make them odd maybe and not too close together. And then you could plug this in and hit enter on your calculator, and it'll spit out a number. And you could plug in your final answer too into your calculator, and it should be the same exact number. So that's just a fun way to check if that's something you want to do. I wouldn't say it's a fun way to check. I guess it's a procedurally correct way to check, right? It's a way to get it right. All right, rewrite using only positivity, right? We're going to be really positive about this problem. This guy is a positive exponent. He's up top. Hey, y to the negative 3, that's just y cubed on the bottom. All right. That's kind of awkward because you're really seeing this negative 5 and you want to put it on the bottom. And so really what we're going to do is anything with a negative power, you can move it. That's why they had that goofy Madagascar cartoon going on the top. Anything with a negative power swaps sides over a fraction line. Hey, y to the negative 3 kind of was over a 1 before, then it swapped sides over the fraction line. Now it's on the bottom. Hey, you had a negative power on the top, you now have a positive power on the bottom, and vice versa for y. All right, this. I'm going to distribute that negative 5 before I do anything, and I'm not going to write it stacked this time. I'm just going to say, hey, x to the negative 1 to the negative 5 is x to the 5. Y to the 3 to the negative 5 is y to the negative 15. And now I'm going to rewrite it with positive exponents only. If you're thinking you could cancel a 5 and a 15, that doesn't work like that because they're different bases. All right, distributive property. That negative 4 is catching both these. So I'm going to rewrite it. I've got x to the 2 to the negative 4 is negative 8. And y to the 3 to the negative 4 is negative 12. And now I want to flip-flop it because I have to rewrite it with positive exponents. And for my people right now that are like, hey, wait, couldn't you just flip-flop it first? Like flip it and then just make it a positive 4 up top? And you actually can do that, right? That could have been y cubed over x squared to the 4th. But that's just for, like, it works sometimes. It's helpful sometimes and not helpful other times. Anyway, hey, this negative 2 is like sitting by itself. It's not touched. X to the negative 2, though, that negative 2 is just on the x. So that negative 2 is hanging out. That's this one. And then x to the negative 2 is just x squared, and that comes down here. Just so you know where it's coming from. All right, big ugly over here on the right. I'm going to move that negative exponent downstairs first before I worry about everything else. So that 6 is hanging out, that y to the 4th is hanging out, that negative 8 is hanging out. I had that x cubed. Oh, wait, that x to the negative 2 is joining the party. It got moved. And that y secretly has a 1, just to remind you, so we're going to do something with that in a second. Okay, fraction line. 6 over negative 8. Maybe you remember how to reduce fractions from back in the day. If you don't, I guess you could leave it like 6 over negative 8. But if this is multiple choice, you might see it like this. I just divided both by 2. Hey, all my x stuff is on the bottom. So that's just x to the 5th on the bottom. Right? They're getting multiplied together so we can add the exponents. And then y to the 4th over y to the 1st is y cubed. I guess I don't need all that fraction there. So again, if you're really not sure if you're right or not, you could store values in the x and y variables. Try the initial one, see what number you get. Try your final answer. Hopefully you get the same number. That's just one way to check if you got it right. All right, we have a whopping 7 problems left, and then this video is done. Then I'll upload this and the answer key to Google Classroom for the people who need it. Okay, rewrite with rational exponents. Rational is another fancy way of saying fractional. So just, if you see this, I hope you're thinking fractional. And they call it that because you can write it like a ratio, right? And a ratio being like a fraction. So x is the base, right? It's the thing with the power underneath the radical. And remember, power over root. So since the 4 is the root, and the 6 is the power, looking like that. If you're thinking right now you can reduce that fraction, you can. We're just not going to. Okay, now here's a fun one. A plain old radical. I'm going to write you a note like over here. Radical whatever. I don't know what. M, I guess. First thing that comes to mind. There's a secret radical and it's 2. That's like saying, hey, if you don't have a number, you're taking the square root of something. Square root is the second root. Remember when you square something, you have a 2 on top? So square root, you have a 2 in the hook. And since you don't have a power, you can secretly think of it as a 1 power. So a plain old radical is the same as like m to the 1/2. Just be advised. I was going to sing the Lion King Be Prepared song, but that's something you really don't want to hear. So right now, this 5 has nothing to do with the radical. It's just hanging out. Hey, that radical x really has a secret root of 2 and a power of 1, so that's really x to the 1/2. Again, if you're not sure, pick a value for x like 13 or 77 or something. Plug it in, 5 times radical 77. It's something. 5 times 77 to the 1/2. It's the same decimal. So you can always check to make sure you got it right. All right, this is horrible and ugly. Not the worst, but So the 7 is kind of doing its own thing. I'm going to rewrite this bottom guy. It's missing its secret power of 1. And that's really the same thing as 7 to the, fraction power. 3 is the root, so it goes on the bottom like a tree root. 1 is the power, goes up high. That's correct and done. If you wanted to show off, flex on them haters, I hope most of you just cringed right there. That's what it looks like. So it just says rewrite using fractional/rational exponents. We did. If you want to write it nicer, it looks like that. Oh, well. Hey, write it like radical form. Radical, power over root, done. Hey, that fractional power on this one only is on top of the y. Only on the y. Power over root, power, there's the root, and then x is just hanging out, so it goes out front. And then this one. That negative means what I'm going to do is I'm going to write it on the bottom like this. Right, that's what negative powers mean. And then I'm going to rewrite it with a radical. So there's my x. Power over root is down low, goes in the hook. That's done. Okay, and then I really like this problem on the bottom. Explain, if you ever see the regions say the word explain, it means use words. Not only that, use sentences. So 125 to the 2/3, you can put it right in your graphing calculator and get an answer. I don't really want the answer. Like, it's nice. You might get half credit. But here's what we're thinking. I'm going to do the math, and then I'm going to explain. So power over root. So I remember when we did this problem back in the day, my math teacher said, all right, what do you think is easier? Squaring 125 and then taking the cube root of that, or the cube root of 125 and squaring that number? Because it's the same thing. Look, I don't know what 125 squared is off the top of my head. Right? It's really big. Like, really big. Ends in a 5. That's all I know. I do know the cube root of 125. What times what times what is 125? Right? That's really what it's asking. Forget about the 2 for a second. Something times itself is 125. And I'll ruin it for you. It's 5. 5 times 5 times 5 is 125. If you're not sure, try it in your calculator. So cube root of 125 is 5. And the squared still hangs out. Hey, that's 25. So explain how it can be evaluated using exponent properties to result in an integer answer. Yeesh. I rewrote in radical form. What I meant to say. In radical form, I took the cube root first. I then squared the result. Sometimes you might find it easier to do the square first and then do the root, right? People compute things differently in their head. It depends on the number on the inside and depends on the other two numbers. So just be advised that, it doesn't have to be the root then the power when you're evaluating this. It could be power then root if you're finding it easier in your head. So that's it on the video. That's all 3 pages. I'm going to then do the answer key, which is the following 3 pages, and post it as a giant PDF on Google Classroom. And then I'm going to throw a Delta Math assignment on there too. So I hope it's all going well. Check in on office hours when needed, and talk to you guys soon. Harbinger out.